Hello class and welcome to section 11.4, which is multiplying and dividing rational expressions. By the end of today's lesson, you'll be able to multiply and divide these numbers. So, multiplication steps, similar to how you would multiply any fraction. First, you're going to have to cross-cancel or cross-reduce if possible. Then you multiply the numerator values, multiply the denominator values, and simplify if you still can. So, for example, I have r squared s over 9s to the third times 3s to the fourth over r. So the first thing I'm going to look at is cross-canceling. So looking at these two diagonal from each other. I have two r's up top and one r on the bottom. So I can cancel that r out and make it go away. And I can cancel out one of those two r's, so there's only an r left. There are no s's to cancel out here, so that's going to stay put. Then I'm going to look at the other diagonal. I've got numbers first, 9 and 3. Both of those can be divided by 3, so the 3 goes to a 1, and the 9 goes to a 3. Then I'm going to look at my variables. I have 4 s's and 3 s's. I can cancel out 3 of those s's and be left with 1 in the numerator. So what this is actually saying, now that I have cross-canceled, is rs, those are the pieces from the numerator that didn't get crossed off, over 3, the piece from the denominator that didn't get canceled, times 1s, those are the pieces that didn't get canceled, and then since everything got canceled out on the denominator of the second fraction, we just have 1. So now we're going to multiply our numerators. We've got rs times 1s, which gives me 1rs squared, or just rs squared, over 3. So we've got our cross-canceling. Then we multiplied the numerators, multiplied the denominators, and there's nothing else to simplify at the end. Go ahead and try this one on your own. Cross-canceling, our a's can cancel out as well as some of the b's. 7 and 21 reduce to 1 and 3. The c's and the d's can cancel out. So after the cross-canceling, I'm left with what is in red. After I multiply, I have 3b over 5a to the third, c to the fifth, d to the third. So multiplying those numerators and denominators, and there was nothing else to cancel. Sometimes when we multiply, we're going to have more complex equations. Similar to what we did in the last section, we want to break these down into factor pairs or take out GCFs if we can. So looking at the numerator of the left fraction, I've got a trinomial, so I can factor. I've got 1 and 4, 2 and 2. To get to a negative 3, I can use the factors of y minus 4 and y plus 1. Looking at the denominator of that fraction, it is already as simple as it can get, so we have just the factor of y plus 5. Then, on the multiplication piece, I'm looking at our second fraction now. So I've got, up top, I can take out a 2, so I've got 2 times y plus 5. And on the bottom, I have a common factor of y. I have a y squared and a y, so I can pull out y and be left with y minus 4. Now that we've simplified, we're going to look to cross-cancel. So when I look at the first diagonal, I have y minus 4, y plus 1, y and y minus 4. I have a matching pair of y minus 4, so those cancel out. Looking at the second diagonal, I have a common pair of y plus 5 and y plus 5. Those also cancel out. So after our canceling, I'm left with y plus 1 over 1 is the placeholder times 2 over y. When we multiply now, I've got 2 times my factor pair, which is y plus 1, over 1 times y, which is y. This is my final answer because there is nothing else to reduce. Go ahead and try this one on your own. So, breaking down 12 into 1 and 12, 2 and 6, 3 and 4, the pair that gets you to 7 is 3 and 4. The denominator of that fraction can't be simplified. Numerator, I can take out a GCF. Denominator, again, I have factor pairs of 1 and 6, 2 and 3. I can use 3 and negative 2 to get to a positive m. Canceling out our matching pairs, I'm left with what's written in red, and then I have that final answer where we multiply the factors and cannot reduce anymore. Division. We need to follow the same steps as with regular fractions. Keep, change, and then flip. Keep the first fraction the same. Numerator and denominator stay in their spot. Change means change the division sign to multiplication. And flip, which there should be a comma in there, flip means that you flip that second fraction over so the numerator is now the denominator and the denominator is the numerator. Once you've done that, it's now a multiplication problem and we use the steps that we had for the previous problems. So, for example, on this one, we're going to keep the first fraction and say m to the 6th, n to the 3rd, over 12j k to the 4th. That stays the same. Change the sign to multiplication. Flip over the second fraction. So my denominator is now m n to the 5th, and the numerator is 36j to the 9, k to the 10th. Now we're going to go through and do some of that cross-reducing. I have 1 m and 6 m's, so I have 5 left over. I have 3 n's and 5 n's, so the 3 cancel out, and I have 2 left over. For the numbers, 36 and 12 can both be divided by 12, so we've got 1 and 3. I have 1j to cancel out, and I'm left with 8. 4 k's to cancel out, and I'm left with 6. So my problem now says m to the 5th over 1 times 3 j to the 8th k to the 6th over n to the 2nd. Now when I multiply the numerators first, and I end up with 3j to the 8th, k to the 6th, m to the 5th, keeping those variables in alphabetical order, and on the bottom I'm left with n squared. There's nothing else to reduce, so this is my final answer. Go ahead and try this one on your own. Cross-canceling with our numbers as well as each of the variable pairs, we end up with 63b over 25. One specific example you're going to want to pay attention to. When it is a single factor that you are dividing by, what this means is this is starting over 1. So you're going to still follow the procedure of keep, change, flip. So we're going to keep 2x plus 6 over x squared. Change the division to multiplication, and then flip this to 1 over x plus 3. I'm going to want to use that same idea of factoring now, so I can pull out a 2 from both of the factors in the numerator on the left, and nothing from the denominator, and nothing can be reduced in the right-hand fraction. I now, however, have a matching factor pair that I can cancel out. So I'm left with 2 times 1 in the numerator, which is 2, and x squared times 1 in the denominator, which is x squared. So when you have that single thing that you are dividing by, you're going to want to start by putting it over 1, and then following the keep, change, flip model. We also can get to the more complex problems with division. Again, you're going to want to use GCF or factoring trinomials to help you out. Up top here, on the numerator, we've got a GCF of 4, so 4, and then y minus 3. On the bottom, our factors are 1 and 16, 2 and 8, 4 and 4. The pair that can get us to negative 10 is negative 2 and negative 8. So I've got y minus 2 and y minus 8 as my factor pairs on the bottom. Then I need to change the sign, and I'm going to flip these 2 over. So these denominator values now are in the numerator. So my GCF is 3, and I have a y minus 8 left over. That was in the denominator, now it's in the numerator. And then again, up top, which is now going to be in the bottom, I have one of those special cases, that difference of squares, which can be broken down into the negative and the positive case. As we've done before, we're looking for those common factors to cross-cancel, and I've got y minus 8 and y minus 8, as well as y minus 3 and y minus 3. So up top, we're left with 4 times 3, which is 12. On the bottom, we are left with y minus 2 times y plus 3. That is all the farther you can reduce this fraction, and that is our final answer. Go ahead and try this one on your own. Again, we can use GCF and trinomials on the left side, making sure we flip on the right-hand side before using the GCF and the and the difference of squares factoring. The red is what we would be left with after cross-canceling. The green is our final answer. If you have questions about this or anything else from the lesson, please let me know when you get to class.